So the first thing we're going to do today is go over the frequently made mistakes from assignment 1B. Before I do that, though, I'll give you an update on the plans for grading assignment number 1. So probably later today, I'll put out a new skeleton. That'll be the skeleton that you'll use for the final grading. And it'll have some really cool regression tests in it, much more thorough and comprehensive than the ones we have had so far. So in addition to addressing my comments, please make sure that your program runs against the test properly. It's very important to do that because you'll lose massive amounts of points if your program doesn't work properly. So make sure that your program passes the test. There's one change that's important to make having to do with the type of exception that's thrown from one of the methods, and I'll talk about that. I'll also put that in the instructions for the final part of assignment 1. People continue to have a bunch of problems, so I'll go through the things that I saw. In addition to reviewing your code from assignment 1B, I also went back and looked over your fixes for assignment 1A, and there were a number of things that still need to be fixed there as well, so I'll go through that. First of all, make sure that you follow the rules and update the Google form when you're done with your code. You have to do that, otherwise your program won't get reviewed or won't get graded. So that's part of the assignment, is making sure that you fill that out so that I know who has submitted it. Also, make sure to comment your code. A lot of people are just writing code. There's very few comments, so I think I mentioned that before, but you have to make sure that you comment your solution so it is more clear what you think that you're doing. And that helps in some of the cases where it's not really clear what you're doing. It helps make it clearer what you think you're doing versus what you should be doing. So here's a couple things. This array constructor has some problems. First of all, you don't need to set m-element data to s-empty element data. All you need to do is just go ahead and initialize the m-element data to the right size, and you don't need to call ensure internal capacity. That's extra work that doesn't need to be done in this case. Here's another thing you can do to simplify the implementation a little bit. You don't need to use this toArray method, which is meant to be used for, I believe it's typed data. Instead, you can use the toArray method that doesn't take any parameters. That works out just fine and is more efficient. So go with that one instead. For the index of implementation, if you use a loop, there's a couple different ways to do this. If you use a loop, the looping version, make sure you have 2 loops as opposed to 1 loop that checks for the conditions in each case, just because it's less efficient to do it that way. It's better to split them out. And that way you don't have to check each time through the loop whether or not something is null, but instead you can go ahead and do the check once at the outside. A lot of people still have a problem. If the parameter is null, then this code is going to fail. So make sure you don't write code like this. If the object parameter O is null, this will be tested for very explicitly in the new tests for the new skeleton that you'll have for the final version of the implementation of assignment 1. So that should blow up if you don't do it properly. Make sure that in the methods that take collections or arrays that you check first to see if they're null. Otherwise, it'll blow up. That'll also fail in the test that you'll be using. There's a bunch of different ways to do add all. My implementation is super optimized. It doesn't actually use a loop. But if you do use a loop, you should use your for each method just because you've implemented it. It's a nice way to try using it instead of using a good old-fashioned for each loop. And you can also do something more efficient than setting a Boolean and then updating it each time through the loop. That's really unnecessary. You can do something else that's more efficient that just checks at the end to see whether or not something has changed. So doing it this way is inefficient because, again, you're doing something each time through the loop, which you don't need to do. This type of code here, where you're deciding what the size of new capacity is, that logic or some variant of that logic should be moved inside the ensure capacity internal method. So it is kind of hidden from you. You don't want to be doing all this extra work before you call the method. That's what the method's there for, to hide that information. A lot of people have problems, various problems with replace all. I'll go through a couple different things I saw. So first and foremost, this is wildly inefficient. Whoops. This code is wildly inefficient because every time through the loop, it's calling index of, which is going to itself go and start at the beginning and search for something. You don't have to do that at all. That's way too, it's probably even wrong, but even if it's not wrong, it's just inefficient. And so instead, this is a particular case where it's probably best just to write a good old-fashioned for loop with an index that you increment each time through. Also, don't use set, because set checks for the range each time, and there's no need to do that because obviously you're running this through a loop of some kind where you know you're not going to be going outside the bounds of the array, so you don't need to call set. Same thing here. This is a more clever implementation that uses for each, which is good and certainly acceptable, but once again, don't call set because that has an extra check that you don't need to do, so there's no reason to have extra overhead in your code. This is another problem, same, also using set. Don't need to do that, inefficient. There's a bunch of other problems that people have where they're going through the range, but not actually updating the underlying data structure. And this is one example where it's simply applying things. This is sort of just a variant of for each. And this one has the same problem. It's not actually updating the data structure at all. So you need to make sure that you're updating the contents of the data structure with the application of the unary operator that's passed in as a parameter. So that's probably the biggest mistake I saw, that many people didn't actually update the data structure. They just applied the operator, which isn't the purpose of replace all. That's kind of more of the purpose of for each. Here's a case where the best way to do this is not to use a lambda expression, but instead to use a method reference, which is just a cleaner, more concise way of doing this. A bunch of people did this. I'm not quite sure why, but this code has a problem in that it'll go through every element in M element data. But if you recall, M element data will often be larger than the active range of the array, because when you call ensure internal capacity or ensure capacity internal, that helper method that is used to grow it by 1, you don't want it to grow by 1. You want it to grow by n. And so there could be a bunch of junk in there. Yes, Allison. So there's a bunch of different ways to do that. The thing you want to be able to do is if you're doing the undergrad version, you'll probably just have to do a loop, a good old-fashioned loop. If you're doing the grad version, you can use a stream in order to do it. Yes, but you have to sort of think, well, no, not really. The best way to do it, you don't need to use an index loop here. The best way to do this is to use your iterator. And the main way to do that is to iterate over this, not M element data. Because if you use this, then it'll trigger your array iterator. And so that's probably for the undergrad version, that's the cleanest way to do it. Does that make sense? OK. So yeah, that's the secret there. Same type of problem here. This is trying to use a stream, which is a pretty good idea, except it's using a stream over the wrong thing. It's using the stream over the M element data. So it's going to end up pulling in all kinds of gobbledygook that's at the end of the active part of the array. And this is just kind of pointing out what we were saying before. What you should use is a for each loop for the undergrads and a method reference. And then for the grad students, you should be using stream.forEach. I think in some of my comments in your code, I didn't say this right. I think in some of the comments I might have said stream.forEach. Don't use stream.forEach. Use stream open close. In other words, this is for the grad student version. For the grad student version, use the stream method that you wrote. That's the factory method that creates a stream. And then it uses the for each method off of that. No need to use this index of. That's wildly inefficient. There's no need to do this, of course, because if you do it right, you're iterating over what's in the actual object itself. So it should not be out of bounds. Don't use an iterator. This is for the undergrad version. Don't use an iterator, use a for each loop instead. Iterator works, but it just is extra syntax that's distracting and unnecessary. Now we're talking about the array iterator class. There's a bunch of subtle issues and problems here, so probably the most important one of which is don't call hasNext again here. It's redundant. Instead, what you should be using is the get method that you wrote, which will throw an exception if something goes wrong. And now, what I'm about to say is very important. For the final version of your solution, I believe it's next. It might be remove, but I think it's next. I've changed the signature of the method so that it will throw no such element exception. That's the exception that should be thrown if it is in the wrong place, if you're trying to iterate over something that doesn't exist. So you'll have to do a little trick to catch some other exception and then convert it into the no such element exception. The good news is that your compiler should complain at you if you don't do this right, because it'll be a checked exception. And so you'll just have to remember how to do that. It's not hard. You just have to think about exception handling. Again, try to avoid rewriting code that you don't need to rewrite. So don't do these kinds of checks. Instead, use the get method, which does this for you automatically. Again, get should be handling this kind of stuff, so you don't have to check yourself. There's a bunch of other things you need to do in remove besides just call remove. You've got to make sure that you keep track of the last element you accessed, because that's important for knowing where things are. So make sure you do more than just call the remove method in the array class. And then final thing, a very minor point, this is for the grad student implementation for try-split. If you're doing a right shift, if you use that funny, greater than symbol, that will do a right shift that doesn't end up doing, I think it's called bit carry or something like that. So you don't have to and out the thing at the end. Yes? Sure. You'll need to use this particular syntax, I believe, because this is coming from an iterator. So it's sort of inside of the array class. So that's just getting to the right place. You could try fiddling around with it, but I think it needs to be array.this.remove. It might not compile properly if you don't use the this there. But yeah, that's a good question. OK, any questions about this? So just to reiterate what we talked about, there'll be a new skeleton I'll put out probably later today, and I'll post a message to Piazza with instructions on what to do. You'll need to carefully copy your code from your 1B solution once you've addressed my comments and any comments that I went over here. Your response, if sometimes, looking over 20-some projects, sometimes I'll miss something. So make sure that you also go and look at these descriptions, just to make sure you didn't do any of these mistakes. So you're responsible for updating everything, moving it to the next skeleton, which is going to have this really cool regression test as part of it. Run the regression test, make sure that your code passes all the tests, which is really important because otherwise you'll lose points. And then when you're done with that, follow the instructions for submitting it, which will involve basically pushing the updated skeleton, which would be the assignment 1 final or just assignment 1 project. Push that up to your GitLab account, and then fill out the Google form that I'll put in there. It's important to remember to fill out the Google form. That's what I use to know who submitted stuff, and I go ahead and grade them. Otherwise, it gets too complicated. OK, so any other questions about the assignment?